Again, welcome to our webinar, and I'm going to turn it over now to our presenters. Thank you.
Awesome. Thank you, Zach. I get to kick us off today. I'm Sarah Powell, and Allie Hardy will be with us very shortly. We are very excited to be here today to talk to you about error analysis in math. And if you do want to continue those math conversations after this webinar, please do feel free to reach out to either of us or both of us. We would be very, very happy to consider more conversations about error analysis or just math in general. We are here with the American Institutes of Research today, so you can check out this webinar and lots of other great resources at intensiveintervention.org. So, our conversation today is on error analysis. And over the last decade, we have been working on database decision making in math. Some of you might call that database individualization or DBI. And we have relied quite extensively on this framework for DBI or database decision making that that the National Center for Intensive Intervention promotes on their website. You probably are very, very familiar with this orange and green and gray framework there on the left-hand side. And in this framework, we start off with our instructional platform. That's that orange portion there right at the top. And that is full of evidence-based practices. And today we're talking about math. So those would be evidence-based math practices that are designed to help students improve their math knowledge. But as we implement those evidence-based practices, we want to progress monitor to ensure that those practices are really paying off for students. And so then as we get to that gray part in the middle of the framework, we make decisions about whether students are making adequate progress or whether they need more intensive supports. And then that brings us to that part that you see there also in green, and we've outlined it in black today. This is diagnostic data. We want to collect diagnostic information to make really smart, informed adaptations to the student's instructional platform. So then as we use that diagnostic data, then we make those intervention adaptations, and then we continue to progress monitor and then make decisions about whether those adaptations are enough for students or whether we need to go back and make some more informed adaptations. So today we're going to focus on that diagnostic data piece, but I'd also suggest we could focus on the other green parts of this framework, anything that deals with assessment. So anytime you are collecting any data from your students, whether it's diagnostic data or whether it's formative data through progress monitoring, or you might even be collecting informal data as you're watching students do math work or talking to them about math work, we can use any of that data and do an error analysis. So as we are talking about today, our error analysis, we will focus on identifying the different types of errors that students are making, and we will try to make some hypotheses as to why they are making those errors. And we're doing this so that we can take our math intervention efforts and best align them with student needs. So that's what we will be focusing on here today. Now, while error analysis is something that you can do everywhere in mathematics, we are going to talk about three big buckets of math today. We'll think about error analysis and what that might look like for students who are working on addition and subtraction. Allie's going to kick us off with that in just a minute. Then she will talk about error analysis and multiplication and division. So if students are working on those types of problems, what might be some common error patterns that we see with multiplication and division? And then I will return with a focus on word problem solving. And we will talk about some errors that students make with word problem solving and how to better improve their word problem intervention based on that error analysis data. So, the steps that we will take today will include the following. And it's really just three things you have to think about when it comes to error analysis. First, collect some of that data, collect some of those work samples. Then, the first thing you are going to do is score those items. Typically, you score whether the student answered correctly or incorrectly. But if you are doing any work in computation for addition, subtraction, multiplication, or division, we would suggest that you score using correct digits. So not only is it important that the student answered the problem correctly, but we then analyze at the digit level. Maybe we're looking at the ones place, the tens place, and the hundreds place, and did they answer each of those place values correctly? For computation, that's really important because as students become better and better with their computation work, we want to give them credit for the things that they're doing within a problem that are correct versus some of the errors that they may be making there. So if you are asking students to answer problems like 25 plus 79, you've got multiple digits in the answer. Or what if students are subtracting 1079 minus 62? Again, multiple digits there. We want to see the nuance. Do they do well in the ones place, the tens place? Oh, they made an error in the hundreds place. Or if you're asking students to multiply 23 times 42, lots of digits in that product, and we want to give students all the credit that they deserve there. So that's just a little side note about scoring computation using correct digits. So first, score the items. And then we want to identify errors. And there's two common camps of errors. There are slips. These are just little careless errors that students make. Oops, they made a slip. Often it's because of students' organization. It may need to be better organized so that they don't make those slips. But slips are often one-off errors or just occasional errors. But you could also identify errors that are bugs. These are persistent errors, and you'll often see a pattern of similar errors when we see these bugs. And many times when students have a bug in their math work, that indicates that they have some difficulty with their conceptual knowledge or their procedural fluency, or it might be a combination of both. So today we'll talk about whether errors are slips or whether they are bugs. And then after you have identified those errors, then we get to our third step in our error analysis, and that is to use all of that information to plan really nicely targeted instruction that addresses those errors, helps students understand, well, that bug, why is it a bug, and how could we think about math differently so that they can move on and continue to do well in their math without those bugs bugging them a lot. So I'm going to go ahead and turn it over to Allie, who will give us some examples for addition and subtraction, then multiplication and division, and then I'll be back to talk about word problems.
Thank you, Sarah. We are going to be leading you all through a series of case studies so that together we can practice this procedure of conducting error analyses. So we're going to start with a second grade case study, and you'll see on the left side of the screen, we have those three simple steps. First, you score. Second, you identify errors and determine if they are slips or bugs. And third, you plan instruction. So here we see some real second grade work samples from a student who at the time was receiving an intervention focused on adding and subtracting within 1000 using base 10 models. So you'll see on these scanned work samples, students were given an equation to solve. And this student used a combination of part whole models and hundreds, tens, and ones charts where they have drawn visual depictions of base 10 blocks. So when you see a dot, that represents a 1. When you see a line, that represents a 10. And when you see a drawn square, that represents a 100. So let's go ahead and look through what scoring these work samples would look like. So when we're scoring addition and subtraction for correct digits, it can be helpful to move from the right to the left so that we can track the students' regrouping procedures. So here we see this first equation, 45 plus 23. We'll get these animations going. We see that in the ones place, that student correctly added 5 plus 3 into 8 ones, and then they correctly added 4 tens plus 2 tens into 6 tens. We'll continue with this scoring on a correct digit versus incorrect digit basis from right to left. And then here we see for the third problem, our first error. The correct answer here is 81, and the student has written the answer 711. So in the ones place, we do have a correct digit. but not in the tens and the hundreds place, which shouldn't have had a digit whatsoever. So what we would encourage you to do is go through and score and then go back and identify those errors. So we're going to keep moving with this fourth and fifth problem. We see another correctly solved subtraction equation, another correctly solved addition equation. And I'm seeing in the chat, we see some part whole models that are not totally accurate. We're not focusing on that distinctly within this webinar, but it's a really interesting error to make note of. Here we have another subtraction equation solved correctly. And now we have another error. So the answer here should be 363, but this student has written the digits 21513. So using correct digits, we do have a correct digit in the ones place, but then all those digits thereafter are incorrect. Another error here with a similar pattern. So once you've scored using correct digits, you want to go back and look at those problems that were solved incorrectly and try to, as Sarah said, make a hypothesis of what the student's error was and perhaps why. So in the chat, I'd love for you to look specifically at this item and tell what you think the error is. What is your hypothesis? What error or errors did this student make? Yep. Instead of regrouping 10 ones into 110, they wrote 11 in the ones place. So we have a very typical regrouping error here. Now let's look at this example here. We have another addition equation. What errors did this student make? And I'm seeing some different ways of describing regrouping. So bundling and renaming, struggling with place value, all of that is accurate. So what errors do we see here? Yep, definitely some place value issues. They're adding single digit with single digit numbers correctly, but they're not using that conceptual understanding of regrouping to assign those digits correctly. Excellent job. So here specifically, they did not regroup 10 ones into 110. They did not regroup 10 tens into 100. And instead, they wrote 13 in the ones place and 15 in the tens place. Now looking at this subtraction example, what errors do we see here? Again, that ones place has a correct digit, but not thereafter. We're seeing a bit of a pattern with this student, which isn't always the case, but it's nice when we do. Okay. So here, instead of regrouping a 10 into 10 ones, well, they did that, but they didn't need to. So let me walk you through this student's work sample, because if you're not familiar with this strategy of drawing base 10 blocks, it might look a little bit confusing here. So the first thing that this student did is they drew 500s, so the 5 squares, 110, so that one line, and then 2 ones, so the 2 dots. And then they only needed to subtract 1 1, but they regrouped a 10 into 10 ones anyways. So what they actually ended up doing was subtract 1 from 12, and then they realized, oh, I still have 10 ones left, and they regrouped it back into that 10 to begin with. And then that kind of unnecessary regrouping and kind of messy work made it to where they thought they had 1 less 10 than they did, which led them to an incorrect answer. So a few different things going on here. And then once you've identified those errors, I think it can be a lot easier to identify patterns when you list out the items that were solved correctly and you compare them to a list of the items that were solved incorrectly. So take a look at this list of correct and incorrect equations and share what you notice in the chat. It's not quite as simple as this student knows how to add, they don't know how to subtract, or this student can add and subtract with 2-digit numbers, but not with 3-digit numbers. And I'm seeing in the chat from Sarah, this is a really interesting time to interview students about their thinking and about their work in these patterns. Yep. When there is no regrouping, they have it down pat. So this student, we see a very clear-cut pattern of needing support with regrouping. And would you guys say that this is an example of a slip or a bug? We'll start with a slow ball. Definitely a bug. Absolutely. And it's probably one of the most common bugs that we see in early elementary school with addition and subtraction. So now that we've identified the bug, we get to plan instruction. So some potential strategies would be, first and foremost, providing explicit instruction, including modeling and supportive guided practice on that topic of regrouping. Maybe we are incorporating those concrete base 10 blocks and pre-drawn or printed place value charts so that we don't have as much drawing of arrows and recircling and messiness happening. We might also support students in verbalizing that process of regrouping using precise mathematics vocabulary. This is where we don't want to tell students to carry the one, or one of my favorite stories is with subtracting. I had a fourth grader who, whenever he needed to regroup, would go, knock, 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 FBI's at the door, open up. Because we needed to borrow a new 10 or borrow a new 100. We want to be really explicit about saying we don't have enough ones to subtract from, so we need to regroup 110 into 10 ones. Or now we have 15 ones, and we can't have 15 ones in the ones place, so we need to regroup 10 ones into 110. We want to be really explicit about the vocabulary that we're modeling and that we're supporting our students in using themselves. And then finally, and I found this is really key in practice, we have to provide sufficient interleaved practice opportunities to support students' computational fluency. I found that when I spent many sessions exclusively on addition, students would then start to struggle with subtraction. And so then if we moved on to subtraction and spent many sessions just on subtraction, students would then start to struggle a little bit more with addition. It's important to throw interleaved problems and pre-planned examples at students so they are exposed to a lot of different types of problems and they don't get stuck in a rut of maybe always regrouping a 10 into 10 ones when they don't always need to. Okay. So now we're going to look at a grade 3 student, and these types of work samples are probably a lot more familiar to you all, especially those of you that taught upper elementary or even middle school, because this student used the standard algorithm. So for this case study, we have a grade 3 student who is receiving an intervention on adding and subtracting using the standard algorithm. And again, to score, which is the first step, since it's computation, we want to look at correct digits and we want to score from right to left so that we can more easily track their regrouping. So here we have 2 correct digits, 3 correct digits, and their first error. The correct answer should be 67, and neither of those digits are correct. We have another correctly solved problem, 3 more correct digits, and 2 more correct digits. So out of these 6 problems, we see just 1 error. And take a look at this error. And let me know in the chat, what error did this student make? This is also a bit of a classic. So I see in the chat, we call this reversing digits. And then I see subtracted as if it is commutative. Commutative. Nice job, y'all. So they subtracted in the ones place without regrouping when here they should have. Absolutely. Nice work. So instead of regrouping, the student just switched the digits and in the subtrahend with the digit in the minuend. And without regrouping, that meant that the student's digit in the tens place was incorrect too. So, like I said prior, it can be helpful to look at a list of all the correctly solved items versus the incorrectly solved items to see if there is a pattern, see what we notice. So what do you all notice here? And this one is a bit more interesting than the prior because there are some inconsistencies. I'll give you some time to think and respond in the chat. They slipped up. Perfect. Okay. Yeah, absolutely. So if you look back at that last item in the green box, we have 70 minus 19. So there they did have to regroup a 10 into 10 ones in order to subtract 9 ones, and they did so correctly. So it looks like if all we have is this record, it looks like this may have been a slip, which is now in that same vein, sometimes additional information is needed to be really, really sure. If we're just looking at work samples, we're forming a hypothesis. Our hypothesis is that it's a slip, but we want to make sure that we confirm that hypothesis. So what we can do is maybe put this work sample back in front of the student and see if they can identify and explain their mistake. And if they can, we know for sure it was just a slip, and we can ask them to, maybe work a little bit more slowly or be a little bit more careful about checking their work. We could also administer additional items and complete a diagnostic interview. So we could write a very similar equation, have students begin solving it in front of us, and then ask them questions such as, what's the first thing that you need to do? Why did you do that? How do you know? So that we can really get into students' thinking. Now, if this student can identify their mistake and perhaps they are able to solve additional similar problems correctly, we would definitely identify this error as a slip. And often slips can be addressed by teaching students how to either better organize their work or use self-monitoring strategies. So in this example, we might encourage the student to always check their work, and perhaps as evidence and a reminder to themselves that they did check their work, they could draw a star by each item after they check it. I know for a lot of students, it can be helpful to draw a line to separate the place value columns, and as a visual reminder that only one digit can go in each of those columns. I have created self-monitoring checklists for students to go through and make sure, did I add and subtract every part of the number? Did I check my work? All those things that we want them to be thinking through without reminders. Sometimes it can help if they have a checklist to go through first before it's more ingrained and a habit. Okay. So we just looked at 2 examples of addition and subtraction error analyses, one with a more place value rooted strategy and then one with a standard algorithm. Next, we will dive into a multiplication and division case study where we have a grade 4 student who is receiving an intervention on multiplying and dividing whole numbers. So let's kick it off with scoring. Now, as I said earlier, scoring for correct digits for addition and subtraction, we want to score from right to left to follow that regrouping. And that is the same here for multiplication with the standard algorithm. But for division with the standard algorithm, we want to flip it and score digits from left to right because that follows the procedure that they took step by step. And when we look at other strategies for solving multiplication and division, such as array models or other more scaffolded multiplicative models, we might score the digits a little bit differently. So it's going to depend on the strategy. But here, starting with item 1, we have a division item that was solved correctly, and we scored from left to right. Next, we have multiplication, where we see our first error. The digit in the ones place is correct, and the digit in the thousands place is correct, but we have some incorrect digits there in the middle. So if we were scoring this so far, we would have 4 correct digits across the first and second item. Next, we have another error where we have the correct digits in the ones and tens columns, but not the hundreds column because we are missing what should be a 0 there with the 6 then in the thousands column. Next, we have a correctly solved multiplication problem, a correctly solved division problem, and another correctly solved division problem. So once you've scored all of the items, let's do some error identify. So take a look at this work sample, and in the chat, let us know what errors did this student make. Okay, so I see in the chat, multiplied, yes, okay. So first they multiplied 4 by 9, but then instead of multiplying 4 times 0 and adding the 3, they multiplied 4 times 3. Excellent. So instead of multiplying the 4 in the second factor with the 0 in the first factor and then adding the 3, they just multiplied the 4 and the 3. Let's take a look at the second example here. I really appreciate all the chat participation. That's a good question, Lindsay, for this problem. The question is, should there be 2 X's in this answer? So typically from what I've seen, and Sarah, jump in if this is incorrect, typically from what I've seen, we don't score the absence of a digit that should be there. We only score the digits that the student provided in their answer.
That's right. That is right, Allie. And that's because often when you present the digits correct, it's just the digits correct. So of all the digits that the student wrote, how many did they answer correctly? We don't often present the digits answered incorrectly. If you did, then I would score based on the place value of the expected answer. But because we often just present in digits correct, it's okay to not do that X in the thousands place.
Thank you, Sarah. So I'm seeing an interesting answer in the chat, and it says, to find the error, you will have to ask the student. They are missing a 0, but we don't know why, and I absolutely agree. So here we see that the student forgot to place a 0 in the ones place as a placeholder before continuing to multiply with the 8, but we really can't track with definity what exactly the student was thinking, what exactly their error was. So I think this would be a great example to either go back and ask the student or construct a really similar problem and watch them solve it step by step. So let's take a look here. This is an interesting one because these are all of these work samples in this webinar have been pulled by the same student. We didn't combine correctly solved work samples from one student with incorrectly solved items from another student. So these are all real patterns from real children. So take a look at this list of items solved correctly versus items solved incorrectly, and I'm curious to see what you all notice and if it's the same thing that I noticed. Yeah, trouble with zeros. And gosh, headed back to addition and subtraction because I'm a former second grade teacher. Subtracting across zeros is a major feat in second grade. So it looks like this student has some difficulty when the factors in a multiplication equation has a zero in them. And there might not be a really clean answer for this, but oh, that's exactly what I had on the slide to read. There may not always be a clearly identifiable misconception. In this case, the student experiences difficulties multiplying whole numbers with zeros. Now, I would err on the side of this being a bug because we saw it happen more than once. At the very least, they need some more practice with similar items such as this. So now that we've scored and we've identified the error, we think it's a bug, and maybe we don't have the ability to go and ask the student to solve more problems or to ask them questions. We want to get started brainstorming some potential strategies for instruction. Maybe we have the students solve similar problems using a different strategy. Maybe they can knock these items out of the park that have zeros in the factors using the area model or using partial products. And the difficulties arise when the student is using the standard algorithm instead. And if that's the case, I think we could have the student practice using a different strategy and then help them make connections between that secondary strategy and the standard algorithm so that there's not so much, I don't know, mishap in between the two. We can, and we always go back to this, but we can provide that good explicit instruction, that modeling guided practice on using the standard algorithm to multiply whole numbers with zeros. And absolutely, we need to provide sufficient practice opportunities to support computational fluency. And Sarah, I'm going to hand it off to you to get into word problems.
Yeah, thank you so much. So, Allie had the opportunity to deep dive into addition and subtraction and multiplication and division. And all of those operations are important for what we are going to talk about now, which, as Allie said, are word problems. So, word problem solving is multifaceted. I'm sure many of you know students who experience difficulty with word problem solving. Allie and I work with a lot of those learners who struggle with word problem solving, and we work to try to make word problem solving easier for students. And word problem solving is tricky because there's a lot of skill that's involved in word problem solving. Not only do students have to have the mathematical knowledge to be able to solve these word problems, but they also need to have reading and vocabulary knowledge to be able to read and comprehend what is asked of them within these word problems. And so when we think about word problem solving and do an error analysis, we can look at students' work samples, but in addition to looking at these work samples and doing the error analysis, you might also want to think about conducting a diagnostic interview. And so Allie has some cues here about diagnostic interviews and some questions that you might consider if you are doing one. So you could ask students to first read the word problem aloud, please. That would tell you quite a bit about students' reading fluency and whether that's a barrier to word problem solving. You could ask students to teach me how to solve this word problem. So that would tell you a lot about students' approach. Where do they start in a word problem and where do they finish and what are the steps that they follow along the way? You could also ask students to tell you more about, well, what is this word problem asking you to find out and how do you know? We're going to talk about word problem schemas here in just a few minutes. And that's one of the things that we say, well, what's this word problem doing? What is the concept that's alive and well in this word problem? And you could also ask students some more. I think this is a why question here. Why did you decide to add or subtract, multiply or divide? Why did you decide to use that graphic organizer? Why did you decide to use that equation? So when you do that diagnostic interview and that information that you get from those interviews, it can really help deepen the error analysis that we can do for our students. Now, if students are not able to answer those questions or feel comfortable answering those questions in the diagnostic interview, one of the things that you may want to think about is introducing an attack strategy for students. An attack strategy helps students work from the beginning of a word problem to the end of the word problem. It's a metacognitive strategy that helps students work through the word problem step by step. And when students are not able to tell you what they would do first or second or third, I would say, you know what? I think this student would benefit from use of an attack strategy. And a common attack strategy that we use, and probably some of you have used in the past, is UPS check, or understand, plan, solve, check. Students first have to understand the word problem by reading it, then they make a plan, then they solve the problem, and then they are encouraged to go back and check their work. There are a lot of different attack strategies out there. I always say I don't really care which one you use. I just care that you use one and that you and your students use it consistently. And then a second thing that you could I guess, get information about from a diagnostic interview and from analyzing students' errors, or thinking about, do students need schema instruction? Schema is just a fancier word for problem type or structure, or think about the conceptual underpinnings that are within these word problems. And a lot of research that Allie and I and our colleagues have done, as well as colleagues across the United States and world, we've done a lot of work in schema instruction, and time after time, we see that it emerges as a research validated practice in terms of support of students' word problem solving. So, with schemas, there are common schemas that students see in the elementary and middle school grades. For example, students will see word problems, which we call total problems, where parts are put together for a total. We see word problems where students are asked to think about the difference between two amounts. We see word problems that students where they have a change that either increases or decreases. And Allie and I are both doing the gestures. We can't even help ourselves when we talk about the schemas to accompany our schema language with gestures. When we get into multiplication and division word problems, there's a common schema where students have groups with an equal number in each group. And there's also a common schema where students have a set that's multiplied a number of times. So as we look at our word samples here, you are going to see some of these schemas and see students using these schemas correctly and sometimes incorrectly. So we'll go ahead and go here. Now, when you are working with students on word problem solving, um, there's lots of different error patterns that students might have. There are computation error patterns. So the similar computation errors that we saw that Allie talked about for adding and subtracting and multiplying and dividing, those may also be seen when it comes to word problem solving. But there's also other errors that you might want to be on the look for. So one type would be the schema. Does the student actually understand what this word problem is about? There are other error patterns that you might see related to whether this is a single step or multi-step problem. A lot of students start off the first few years of their word problem career all single step word problems. So as they get to third grade and fourth grade, and now we have multi-step and sometimes multi-schema word problems, a lot of students will do the first thing and then they'll just circle their answer and be done. I did it. I only have to do one thing when I do word problem solving. The joke's on them because sometimes they do have to do two steps or three steps, or I just recently saw a four-step word problem for fifth grade students. Another error pattern that we might see, and we're going to see this today in some of our examples, is errors with the location of the unknown. The first few years that students solve word problems, so often they're solving for the quote answer, that sum or difference or product or quotient. But there are a lot of word problems that ask students to actually identify the missing addend or the missing subtrahend or minuend. That's the number you start with and the number you subtract in subtraction. A lot of times there's word problems where there's a missing factor, and those can really throw off students. And so that is an error pattern that you might be on the look for. And then another error pattern that you could look for in students' work samples, but would also be great to get information from in a diagnostic interview, is how do students interpret the vocabulary of word problems. There's the math vocabulary within the word problems, and many times students fall into this trap of identifying key vocabulary terms in math and tying them directly to operations. I bet that you know some students that if they see together in a word problem, or all together, or combine, or total, they will then add to solve the word problem. But that is a tricky trick because it doesn't work all of the time. And in fact, keywords work only about 50% of the time for single step word problems and less than 10% of the time for multi step word problems. And so, our students identifying those keywords and linking to them to the operations, that might be an error pattern that you're on the look for. But you could also consider general English vocabulary. Maybe students are tricked by locations or names or other vocabulary terms, such as the word problem over here on the left. We've got a restaurant. That's a big term. What's a bill? A lot of times students might think a bill is like a duck bill, but we're actually talking about a receipt at a restaurant. What does it mean when things are shared among friends? Who's a person? So there's a lot of vocabulary that could be tricky for students, and you might see an error pattern with that vocabulary there as well. All right, so let's go ahead and look at some error patterns. So our case study here is a grade 5 student who's been working on a word problem intervention focused on single step word problems. So let's go ahead and look at some of their word problem work. Now, before I talk through this word problem work, I do want to say the student has been working on an intensive intervention in word problem solving, where two things have been a focus of that intervention. First is use of an attack strategy. So if you look closely, do you see that UPS check? It's written vertically on each of the problems. Thanks, Allie, there. The student has checked it off after they've used it, but it's there. So that's the attack strategy. And the student has learned a lot about schemas. They've learned about the total schema, where parts are put together for a total. And on this work sample, they've also learned about the change schema, where an amount increases or decreases to a new amount. So where I see P plus P equals T, that is for the total schema. Part plus part equals total. And then where I see ST plus or minus C equals E, that's start plus or minus the change, the C equals the E end amount, and that you can use for change problems. So that was a lot of background information to first score the student's work. So for item 1, the student answered this word problem correctly. That's great. But for item 2, this problem was scored incorrectly, and we'll talk a little bit about why that is. Item 3 is correct. That's great. Item 4 is also correct, which is awesome. But 5 was answered incorrectly, and so was 6. So let's go ahead and look at the problems that were answered incorrectly and try to think about some of the common error patterns that emerge from these student work samples. Hello, Pamela. I see in the chat. All right. So for item number 2 here, the student answered this problem incorrectly. I'm going to give you 20 seconds to read this word problem and look at the student's work sample to try to identify what the student did here. All right, in this word problem, Nina has a bag of chips. She eats some of the chips, and there's 7 chips left. How many chips were in the bag to start with? The schema of this word problem is that it is a change problem because there's a change in the number of chips as Nina eats those chips. So the student identifies the schema mostly correctly. They write ST minus C equals D. Well, we could talk about that for another time. But start minus a change. And they see that there's a decrease in the number of chips as Nina eats those chips. So they have that minus sign there. So lots and lots of really great things going on. So they've used their attack strategy with the UPS check, and they've identified the schema correctly. But then, where the student went down an incorrect path is they placed the numbers in the equation incorrectly. So, my question for you is why might students have written 15 as the start amount? What might some of your students think or do? So, if you want to go ahead and answer that into the chat, I would love to get your answer there. So, why might students have written 15 as the start amount? Yeah, it's the largest number. It's the first number that they run across in the word problem. And often when we write and we fill in equations, what do? We fill in them in left to right. But one of the things we teach our students in our word problem intervention is that we don't have to fill in that equation left to right. Let's fill in the information as we determine it. So in this situation, 15 is actually the change, 7 is the end amount, and then they had to figure out how many there were at the start or how many we had at the beginning. And so they place the numbers in the equation incorrectly. The math looks great, right? I like that 15 minus 8 does equal 7, but that's not the math required to solve this problem. And when they wrote 8 chips in the bag, I love the label. That's awesome. That they're talking about the chips in the bag, but it's not a reasonable answer. It doesn't make sense that I start with 8 chips in the bag, then I eat 15, and then there's 7 chips left. And so that's one of the things that we could also find an error pattern here is whether the answer is reasonable or not. Thank you so much for all the chat. It's so great. So here's another, this is item 5. So if you want to go ahead, I'll pause for just about 15 seconds to read this word problem. So here, this is also a change story. There's some coins in the piggy bank, and then after putting 22 coins in the bank, there were 35. How many coins were in the piggy bank at first? So this story is also changed. This time we have an increase because we're putting coins into that piggy bank. But this is the same student who had that issue with item number 2. We're now on item number 5. They really like putting something in the start amount, and they're having a hard time working on these change problems where the start amount is the unknown. So here they use the attack strategy. I see the UPS check. They identified the correct schema. Love it. But they placed those numbers in the equation incorrectly. They did some okay math here. We got to check on 35 plus 22, but they're actually the math is not that great as they've got it backwards. It's 57. But the answer is not reasonable. It wouldn't make sense that they have 75 coins. They put 20 coins in the piggy bank, and now there's 35. So we can see that this student is just doing a lot of this answering, but actually not doing the reflection piece of does that make sense? And then we'll see a very similar pattern here with item number 6. I'm not going to spend too much time on this one. But the student starts with some money, then they bought a pencil, and now they have 10 cents left. And so this situation actually maps on pretty directly to the other 2 items that the student answered incorrectly. They did well, attack strategy and schema, great. The numbers in the equation are incorrect, and the answer is not reasonable. It doesn't make sense that I would start with 15 cents, spend 25 cents, and have 10 cents left. That would be some magical money if that actually made sense. So what we see is of the items that the student solved correctly, they solved 3 total problems correctly, 1 with a missing total and 2 with a missing part. So they have worked on problems where the answer to the word problem isn't always the last part of the equation. So they do understand that for total problems. But for change problems, they are really having some difficulty when they are working on those change problems with that missing start amount. So, and because we saw it consistently, probably like all of you, you would say that is a bug, Sarah. And that would say, because that's a bug, we need to provide a lot of instruction on those change problems that have a missing start amount. But I would also say any schema problems where I have an unknown that isn't the sum, the difference, the product or quotient, we probably need to do some work on that. So as Ali suggested, a really good way to start is to think about providing some explicit and systematic instruction. That's that modeling and guided practice opportunities on word problem solving, but specifically on those change problems that have a missing start. I'd also be interested to see how the student does on change problems that have a missing change. I'd love to see how they do there with those, and that might require some explicit instruction. But then another potential strategy that I would really want to pull in is thinking about checking your work and asking yourself, does the answer make sense? Here we can see that the student just answers, and that's what we ask students to often do. But I want them to sit back and say, does that answer make sense? Is that reasonable? So we could prompt students with some questions that if Nina ate 15 chips, could there only have been 7 chips in the bag? Here's where I may even want to get a bag of potato chips and put 7 in it and say, okay, 8 15 out of here. Is that possible? It's not possible. Or maybe I could ask, could Mateo have bought a pencil for 25 cents if he only had 15 cents in his wallet? That is not possible as well. So we want to give students some real life experience with checking for reasonableness. And then, as always, all math goes back to practice and practice opportunities to support that fluency, that accuracy, and ease with math. And so we would want to give students as many practice opportunities as possible with their word problem solving. So, in summary, today, we framed a lot of our discussion around error analysis off data collected within that database decision making or database individualization framework. But anytime when you're collecting diagnostic data, formative data, or just observational data, you can do errors based on any of that data that you collect. And as Ali and I talked about today, there's really 3 steps that are involved here. First, score the item. And remember, for computation, do check for correct digits, not just correct answers. And then identify the errors. Is it just an oops, oh, that was a slip. I just made that one-time mistake. Or is it a consistent bug? And we've seen some bugs alive and well today in students' computation work and in their word problem work. And then third, really think about planning your instruction to target those errors, to either go back and fix those errors, or sometimes you can be savvy with your instruction and teach ahead of errors. So that's where explicit instruction comes into play. A lot of really great modeling will help students see how to approach problem in a correct way so that they don't pick up those bugs, those misconceptions, and you don't have to undo that learning that they have previously picked up. So thank you so much for joining us for this webinar today. We are going to have a few moments for questions. So if you want to type those into the Q&A or to the webinar chat, we will definitely address those. But before we get those to the questions, we are going to turn it over to Zach, who's going to share some of the really, really amazing resources from the National Center on Intensive Intervention. Zach, you want to take it away?
I think for this slide, I believe, Ali, do you want to do this one? Because I think this is some of your content as well.
Sure. So a lot of the content that we have learned regarding error analysis is from this great book called Error Patterns in Computation. So this would be a really great resource if you are particularly interested in helping identify error patterns in computation, which is the title of the book. We also have this NCII error analysis and math tip sheet, which we may touch on a little bit later. And then in the chat, I know there were a lot of questions about how to move forward with schemas. Where can I get a video of those word problem gestures? And here we have a Project Spiral video on slips and bugs. But if you follow this link, you will be brought to the Project Spiral YouTube page where we have a ton of videos specific to word problem solving. You can see videos of our team explaining how to use the UPS check attack strategy, how to solve every schema of word problem with that associated schema equation, and much, much more. So with that, I will turn it back to you, Zach.
Thanks, Ali, and thanks, Sarah, for such a great presentation. So I just wanted to briefly share our NCI resource that we developed based on the great work that we saw through Math Spiral. And we put together a step-by-step guide that goes along with this process that our presenters just shared. And so it's really, the purpose is to help identify common types of errors in students' math work and then use this information to better align the intervention with students' needs. So it's a brief resource that really walks through some of what was just shared. If you go to the next slide, I just have a few graphics from this resource. Can you advance one? No problem. Yeah, so again, just demonstrating how to evaluate each numeral in the student's answer. We have some, easy, quick guidance around that in this resource, if you're looking for that. Then on the next slide, we just have some examples of error analysis. So kind of a couple examples of student answers and the teacher examples of how the teacher thought through what they were seeing there with those errors. And then finally, before we turn to any questions, I think one of the nice things about our resource is, on the previous slide, is that we have some linked examples of strategy application. So Dr. Powell has some videos on our NCII website, as well as Math Spiral that we link to. So some nice example strategies that you can use to address specific types of errors. And we have an upcoming error analysis webinar that I wanted to flag for everyone if you're interested in writing. Dr. Katie Valentine will be presenting on June 24th on error analysis in writing. So please feel free to join us for that one as well. We'd love to have you. And the event survey is here. And I think with that, we're close to wrapped up, but I don't know if there's any questions that folks see in the chat that we want to address before closing.
Let's see. So there was a question about, do we have a webinar like this specifically on solving word problems? I shared some resources that have been into the chat, especially on mathspiral.com. We have a lot of videos around word problem solving and a lot of free and downloadable materials there. And also in the National Center for Intensive Intervention, I don't know how many of you are familiar with this. I know some of you are. There is a free math course for adults about how to provide math intervention. And if you write this down right now, Module 5, Part 2, and maybe someone can link to this in the chat, is over an hour on word problem solving. I had the honor of putting this course together for the NCII, and it goes into all the word problem schemas. You'll see me set up and solve word problems. I talk about attack strategies. There's word problems for you to set up and solve. And so if you do want a lot more information on word problem solving, it's that NCII math course, Module 5, Part 2. I'll type it in the chat. That's the deep dive into word problem solving. There you go. Thanks, Zach. Thanks for putting it in there. Yep. Another question that came in was, do we have assessment resources? Like, where could I find these probes? Most of the data, some of this data I know is from when Ali was a teacher, and a lot of this data is from our pre-test data that we've done within our research programs. So some of this data was collected on standardized assessments. All of the word problem measures we have designed ourselves. I dropped into the chat a word problem screener that Ali and our team developed that we use to identify students who need word problem intervention, and it's free and downloadable, just 8 problems. But if you ever want any other word problem resources, we have quite a few of them. So just email me or Ali or both of us, and we'll try to connect you with some free assessment resources. And I think those were all of the questions that I saw into the chat. If there's any other questions, please go ahead and drop them in. It's been a pleasure to be here with you today.
Thanks everyone for joining today.